Good afternoon, and thank you for coming to Detecting Brand Impersonation with DNSRazzle. My name is Skip Cruse. I'm the Adversary Simulation and Red Teaming Lead for Baxter Healthcare, and I'm presenting with my co-presenter, Ellen Lakin, who's our Global Lead for Threat Intelligence. I know you've all probably heard a bit about Baxter so far, but let's just talk about Baxter for a little bit real quick. This year, Baxter is celebrating our 90th birthday as a global healthcare company with a mission to save and sustain lives. And this year also marks our 76th birthday of our presence in Mexico. A little bit about myself. As I said, I am Baxter's Red Team and Adversary Simulation Lead. I've been in InfoSec since 2010. I'm a specialist in offensive security with concentrations on purple teaming and adversary simulation. I race BMWs as a hobby at a national level, and I'm also a video game enthusiast. I'm originally from Florida, and I like to travel. My GitHub, Twitter, and LinkedIn can be found at the bottom of these. Just feel free to scan any of the QR codes, and it'll take you directly to the profiles. And now my co-presenter, Ellen's going to tell you a little bit about herself.
Hello, everyone. I'm Ellen Lakin. As Skip said, I am the Global Threat Intelligence Lead at Baxter. I've been on the InfoSec team at Baxter since 2016. Some of my areas of interest include or specialty are stakeholder-centric threat intelligence, threat actor analysis, and then also internal and external risk analysis of the cyber threat landscape. In my free time, I'm a very amateur baker, knitter, and love doing yoga. I was born and raised in the Chicagoland area, and I'm happy to still call it home. And my LinkedIn and my threat intelligence Twitter QR codes are on the slide as well.
Okay. Well, thank you, Ellen. Let's go ahead and get started, and we'll come back to you in a little bit. So what is DNSRazzle? DNSRazzle is an open source tool that I developed last November that assists in the automated detection of typo squatting, homoglyph domains, phishing sites, and brand impersonation. It uses computer vision and AI to automate the detection of imitation domains. It's written entirely in Python 3. It's cross-platform. It'll run on OS X, Linux, and Windows. There are a couple bugs in it right now in the M1 adaptation of OS X with the ARM porting, but I'm working on that. Has the ability to offensively detect and fingerprint attacking infrastructure if you want it to. And it's available for free on GitHub, and it's Apache 2.0 licensed. What is computer vision? Computer vision is a technology that seeks to develop techniques to help computers see and understand the content of digital images. It's fairly straightforward to search text in a website or in a file. It's a lot harder to search the content of images or videos. In order to index and search images on the web, algorithms need to know what the images contain. And this means what's in it, not just what the meta tags that are uploaded by the person that uploaded it to the internet says it is, so that you can't just say a video is a dog, but when you play it, it's a cat. The goal of computer vision is to use observed image data to infer something about the image or video. And how exactly can computers see? Well, the answer to that is image processing. Image processing is the process of creating a new image from an existing image, typically simplifying or enhancing the content of the image in some way. It is a type of digital signal processing, and it is not concerned with understanding the content itself of the image, just the contours. DNSRazzle uses the open computer vision and scikit image libraries available in Python. There are two main ways that you can do computer vision with images. One is with the mean squared error equation. The other one is with the structural similarity index measurement. Now, MSE is very easy to implement, but it also has its share of problems. Whereas SSIM is harder to implement. It solves a lot of the problems that were presented by the MSE equation, and it was developed by Zhu Wang and other co-authors, and I have the link to their white paper on it at the bottom of this page. It'll also be available in a reference page at the end of the slide, or at the end of the presentation, sorry. What are the differences between the MSE and the SSIM. Well, if you look at the two equations here, you can tell that one's a little bit more complicated than the other. The mean squared error equation is what seeks to find the mean squared error of two images, and that's equal to the sum of the differences between the two images. In order for MSE to work, the images must be the exact same dimensions. With SSIM, it's more complex, as you can clearly see, and SSIM attempts to model the perceived changes in an image, in the structural information, whereas the MSE does not and just estimates the perceived errors of the image. The SSIM value can vary between -1 and 1, where -1 is completely different and 1 is absolutely identical. To demo the SSIM equation, I've written a POC script that anybody on here can scan this code and scan this QR code and download, and it can be found on my GitHub at the link provided. Let's go ahead and I'll walk you through a quick demo on how the SSIM works. So if we Python 3 F, we're going to compare Google. Oh, one too many O's. Sorry. We're going to do google.com for the first site, and we're going to compare that to, I don't know, let's go apple.com. And then I'm going to do a capital S on this script so that it will also show the actual images that it's creating on the background. So it's going to go ahead and it's using the Selenium WebDriver to go ahead and grab a screenshot of each of the provided domains. And as you can see here, it's given us back a SSIM score of 0.75. And here are the generated pictures. So here's the initial site that it looked at for Apple. As you can see, it draws bounding boxes on all of the different artifacts on the page to help find the errors. So if you look over here at the Google page now, and you can also see the bounding boxes here, there's the ones that don't match. And so the ones that are 1 for 1, that counts towards the score positively. The ones that that aren't count negatively. It also goes through and converts everything to grayscale before it does the diffing on the images. So you end up with this being the diff image, and then this being the threshold of what it can actually see. To get out of this on your computer, if you do run the script, you just got to hit escape, and it takes you right back here. DNSRazzle is the tool itself that I have developed. If you'd like to see it in action, you can download and run it yourself. Like I said earlier, DNSRazzle uses the Selenium WebDriver to capture screenshots of domains. It then uses computer vision to compare the discovered domains to the original reference domain's screenshot using the SSIM equation. It'll then return the SSIM score, and it will output whether the pages are identical, similar, or different using a modifiable logic tree that you can train based on what thresholds you see for matching your websites. It is also found on GitHub, and as I said earlier, it is under the Apache 2.0 license, and it's free for you to grab and play with yourself. If you scan this QR code, it'll take you directly to the repository. All right, so I've got an actual demo here of DNSRazzle, and because the live demo gods are not kind to me, I have made a video of it that I can talk you through. So we're not going to use any of the advanced features at this point of DNSRazzle for this demo. We're just strictly going to give it a reference domain and an output directory. And for that domain that we're going to compare here, I'm using apple.com, and I'm having it output everything to /temp. So as you can see, it's outputting the folders there. It took a screenshot of apple.com, and now it's processing the domain permutations. After it finds all the permutations, it goes through and it runs the whois queries on the discovered domains to get the whois data, and also does dig records. Once it has collected all it'll display everything that is a valid domain, dump all of the DNS records like this, and then it will go through, and if you'll notice at the bottom, as it's collecting the screenshots, it'll give you the SSIM score. So apple.com is different from appleb.com with 0.49. Or this one right here, which is apple.com with applec.com with a score of 0.62. So we know that these are different, and they are not the same website. How do I change my slide now? There we go. Additional DNSRazzle features. Like I said earlier, it is capable of fingerprinting real discovered attack site infrastructure. To do that, it uses the Nmap library in Python. And be very careful with this, as it actively reaches out from wherever you're running the DNSRazzle at. So if you're trying to be sneaky and not let your adversaries know that you are actively fingerprinting their setup, you will want to run this from a throwaway VPS or an AWS instance, maybe a DigitalOcean droplet, something like that, just not from your actual NetBlock or CIDR blocks, unless you want them to know that you're looking at them. It'll return the whois data, the registration data, and the DNS data, and that's going to be the registration date, modification dates, the name servers, MX records, and the A records. You can also have it generate a DNS recon style report for each of the discovered domains, which that will output in CSV into a subdirectory of whatever directory you tell it to put the output to. You can also specify a custom user agent with this tool so that when it fingerprints outbound, it doesn't show up as just curl or the Selenium WebDriver or anything like that. To extend the permutation engine's capability of generating permutations, you could specify a dictionary file that will then add those dictionary words or strings into the permutation engine when it generates all of the different domains that it's going to check. You can also do this with a top-level domain dictionary and specify TLDs to add when it does the permutations. So say you're having it look at Baxter.com. You also want it to look at Baxter.mx and Baxter.co. So you would make a flat file and just drop one entry per line, the different TLDs that you want to run, like .co, .mx, .co.uk, etc. The one other thing that it has the ability to do as well is you can just have it generate a full list of all the domain names that it's going to with the permutation engine, and then not do any touching or reconnaissance or anything on it, and just have it do a dry run and dump to standard out the domain permutations that it's created. As for what we do here at Baxter with the DNSRazzle output, I'm going to throw the ball back over to Ellen so that she can talk a little bit on how we use this.
Yeah, so this is where this output falls into the hands of the threat intelligence team. So our main goal with the output from DNSRazzle is to identify potentially malicious impersonation or typo squatting domains, and then to reduce the risk to our organization and to other organizations from these domains. So if you were to run this for your organization and you get the output, one of the first things we do is we do an initial analysis to get our final list of potentially malicious domains. And that initial analysis, one of the biggest things is to remove false positives. There are times where it will take a human to view the screenshots and see that it belongs to a legitimate business that might just have a similar name to your corporation or something along those lines. And one of the biggest things is we want to ensure we're not trying to take down or block any legitimate business pages that could possibly disrupt a business process. The other thing that we focus on in the initial analysis are the newly created or recently changed domains. Those are ones we like to focus on because they're ones we wouldn't have seen the last time we ran the program. So then after that initial analysis, we'll have our final list of potentially malicious domains that we want to do a little bit of further investigation on. And the point of this further investigation is at this point, we have potentially malicious domains, and there's three different levels of protection or risk reduction we can do with them. One of the easiest things we can do is you can block within your own organization any internal communications or communications to those domains, or block any incoming emails to those domains. But that is just going to protect your organization. The next thing you can do is you can submit these potentially malicious domains to global block lists. These will alert the security community that they are not your company, and they're not your corporation, and that you are suspicious of them. And you'll want to do this if you don't have concrete evidence that these pages are used for malicious activity, but you're suspicious of them. And you want to alert people so that they know if they're receiving any communications from those domains, they're not your company. But then the best thing that we can do, and the best way to reduce the risk of the organization, is if we have legitimate and concrete evidence that these domains have been used in malicious activity, say business email compromise scams, or impersonation domain scams are used to host phishing sites, things like that. If we either have a screenshot of the malicious hosted content, or if we have a copy of the email sent from the domains trying to impersonate someone from your corporation, then we can actually we can reach out to the registrars and the hosting providers to try and get these domains taken down. That's where those additional features where we're gathering the who is information, and so the registrar, the creation date, and things like that gets really important for threat intelligence, because it makes this information actionable, and gives us something we can actually do to try and get this attacker infrastructure taken down. The other thing we can do with all of that additional information that DNSRazzle gathers for us is we can try and fingerprint more of the attacker's footprint and infrastructure. So from there, we'd have the creation date, but also the users who created the registrars. So you can take that and see if they've created any other domains that you are unaware of. So there's a lot of different information you can go off of when it comes to just the who is information that DNSRazzle is gathering. And then there are some times where it gets a little tricky, where the registrars might not respond, might be unresponsive, or they respond and they're saying they're refusing to take action. They don't think you have enough evidence to get this domain taken down, or they are not on the same lines believing that that activity is malicious. That's where we can reach out to our partners at the FBI or local law enforcement, or just government agencies. They are trying to also track down bad actors that are trying to impersonate organizations and companies within their countries. And a lot of them have more access and ability to take offensive action against these threat actors to really try and get these domains taken down. Because, like I said, back to our main goal, which is really to reduce the risk of to your organization and other organizations from these domains. One last thing that I want to go back to is if when you're trying to find additional information and you don't have they aren't necessarily hosting something malicious on the web page or the domain, or you don't have a copy of the email or of any malicious emails the threat actors might be sending from the domains. One thing you can be aware of are domains that are registered but not hosting anything on their web pages. Say they're blank web pages, or they look like they're typo squatting being offered for sale, but they have MX records established, which means that these domains are set up to receive and send emails, but they don't have any legitimate web presence. So that puts them higher up on the suspicion level. And I think those are riskier domains to be aware of than necessarily just typo squatting domains. But then again, you also want to be aware of typo squatting domains, because threat actors can easily purchase the typo squatting domains. They're being offered by popular domain registrars like GoDaddy and things like that. So they're very easy to pick up and purchase.
All right. Thank you, Ellen. A feature in DNSRazzle at this point right now, it will output in the block of output that it creates if there are just MX records on a domain and no actual A record, to let you know that it's capable of sending mail without a web presence. A couple other things that are coming down the line in DNSRazzle before I move on is we are a feature to, if the similarity is glaring, or the dissimilarity is glaring enough in the websites between the reference domain and the compared domain. I'll be adding the feature to automatically send a takedown email to the registrars or the host that hosts the content. Another feature that's coming down the line is I'm going to start using YOLO image processing, or you only look once image processing, to be able to actually use trainable neural networks for this, to be able to identify specific artifacts within websites, or like things like specifically look for just a logo or a web form so that you can tell that it's trying to imitate like a PayPal login screen or a Google login screen, things like that. That's coming down the line. A lot of big features are going to be coming out soon. Finally, we're running out of time here, so just give me a few more minutes of your time. Finally, I want to tell you guys about our Global Center for the Delivery of Information Technology Services. It's located in Zapopan, Jalisco. We have a couple of teams of highly specialized professionals providing solutions in critical areas of Baxter's operation globally in this GDC. We invite you to scan the QR code on the bottom left corner of this slide, and that will take you to our careers page if you feel like joining us. The references that I listed earlier in this talk, the first one was the site compare on my GitHub. That one's just the POC for using the SSIM. The second one is the actual link to DNSRazzle. PyImageSearch.com had a great blog post on the implementation of both MSE and SSIM equations and how they differ and how you can test the differences to see which works better for your process. And finally, the final link here is the link to the paper that Wang et al. Wrote on how the SSIM was developed as part of Scientific Python. It's a long read, but fairly interesting. I want to thank all of you for coming to this talk today. I hope you guys have had a great afternoon, and I hope you've learned something from this talk. If you have any questions about DNSRazzle, please feel free to reach out to me on one of my socials. I'll be happy to answer any questions you have. Thank you and have a wonderful day.